For this experimental demonstration, we're applying Pascal's principle to blood pressure.
For this experimental demonstration, we're not using any hazardous materials. We'll just need alcohol wipes. You'll also need a sphygmomanometer and a stethoscope. Physics is a scientific study of the properties and behaviours of matter and energy. Areas of study are categorised according to size and speed. Classical mechanics deals with large and slow properties and has many subdivisions, including continuum mechanics. Pascal's principle is under the fluid division of continuum mechanics.
Now we know what Pascal's principle is concerned with, let's take a look at the definition.
A pressure change at any point in a confined, incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere.
Okay, so let's break it down.
In physics, a fluid is either a liquid or a gas. Incompressible fluids like water or blood won't change in volume or density when compressed. A closed circuit confines a fluid from the outside world, like a Galileo thermometer, a water balloon, or the human circulatory system. In biology, there are closed circulatory systems, like what humans have, and open circulatory systems, like what insects have.
The equation for Pascal's formula is pressure equals force divided by area. Now let's apply this to biology.
Biology is a study of living organisms, including their structure, functioning, and evolution. Subdivisions of biology include homeostasis, which is concerned with maintaining balance within an organism against external factors, and blood pressure is a type of homeostatic regulation.
How does blood pressure actually work?
The left ventricle of the heart contracts with force, which creates a pressure and moves the blood and incompressible fluid around the closed circuit of vessels within the human body. Blood pressure is measured in this section of the circuit. In the first stage of measuring blood pressure, the blood pressure cuff is placed around the patient's arm. The pressure is increased to a point where the brachial artery is actually closed off. Next, the pressure will be slowly decreased to allow blood to start filling the artery. In this stage, we'll hear Korotkoff sounds, which are different from heartbeats. Heartbeats are just the sounds of the heart valves closing, whereas Korotkoff sounds are only heard when blood pressure is being taken because it's the blood refilling the artery caused by the pressure coming from the left ventricle. In the last phase, the artery is completely open and blood is flowing through like normal. Just like the first stage, you won't hear any sounds here.
In this experimental demonstration, we're going to test how much force is produced by the left ventricle.
To do this, we'll be using Pascal's principle, but we need to change things around a bit so that we're finding force, which is force equals pressure times area.
We'll be measuring the pressure in millimeters of mercury, then converting this to Pascals for the equation. For area, we'll be using the cross-sectional area of the brachial artery in meters squared. The measurement we'll be using is from a reliable journal article. We'll be using these two values to measure the force in newtons.
So we'll end up with an equation that looks like this. Now let's look at the experimental demonstration.
In this experimental demonstration, we'll observe if an increase in left ventricular force has occurred after exercise. To do this, the blood pressure will be measured from rest and again after each interval of exercise. Each interval will comprise of 5 burpees. The completed data sheet will be available at the end of the video. Now we're ready to demonstrate. Let's get started.
Remember to use the alcohol wipes to sanitize the equipment beforehand. The first thing we're going to do is take the blood pressure at rest. Next is the first interval of exercise, which is 5 burpees. We'll take the blood pressure again after this and repeat the process for 5 intervals. By using Pascal's formula, we can find that there is actually an increase in left ventricular force after exercise.